Okay, let's start today's tutorial. In this case study, a structure cell spans a 10 meter gap where one of the support is 1 meter higher than the other, as you can see here. The structure must be capable of carrying a load, so the point load is suspended 4 meters from the left-hand side support. So I think this work will help you have an idea to create your model for your final assignment. Suppose you have the solution for this structure like this, and now you want to create the three-dimensional model on Revit structure, and that's the reason I will give you this tutorial, and I hope that to give you some tips on how to build a model effectively. So the first step is to define the grid line in plane and elevation. Then the creation of the foundation. Next, we create a new truss template and put it into the model. Create the support system. Copy the truss system to create the three-dimensional model. And add the diagonal element. And here is the dimension in the elevation of the bridge, and we will use the Revit structure to create this model now. Okay, let's start using Revit. First, we will create the new project using the structure template. Okay, and as usual, we should save the project to your laptop. In this case, I choose the name Balsa Bridges. Balsa Bridge. Now, for the first step, we define the cross-section of the beam that we will assign for the truss bridge. And as we have not the timber beam in the cross-section library of the project, we need to load this one from the library categories of timber. So let's do this. Here we load the family for the beam, so we need to use the structure framing libraries. This one. And then we use the wood and timber. We can select a section and then we define the new one. But first, before we define the dimension of cross-section, we need to unify the unit system for the project. Here I want to use the centimeters unit for the length instead of millimeters. Now we create the new cross-section with the dimension of 3 by 6 centimeters. So yeah, we rename this one and then change the dimension 3 and 6. Okay, we finished to define the cross-section, and now we will build the truss model. Let's take a look at the truss library that existed for the project. You can see here we have only one truss type for the moment, and so you can load the truss template for the external library as I showed you in the previous tutorial. And for today's example, we will create our new template by using create a Revit family file. Revit provides many templates to help the user create a new family model. For example, this exercise we will use some basic structure trusses. So first, we define the length. The total length of our structure is 12 meters, so 12,000 millimeters. As the unit actual use for this template is the millimeters. So the same for the height, we define for 2 meters. Okay, now let's define the reference plane. In fact, the idea of using the reference plane is to define the relative distance between the main dimension of the structure. So each template have a different properties and criteria, and here we need to define 8 vertical and 3 horizontal reference plane for our structure. Yeah. So we can use the measure to define the equivalent distance. Now it's the horizontal reference plane with the distance of 500, and we use the top chord to define the top chord of the truss system. The bottom chord. And here is the web. You can see it's easy to create the model from this template. Okay. And now we load this template into project. And you can see in here the family one is already loaded. Next step, we define the grid, the construction line for our structure. We know the distance between the construction line. Is 10 meters and then 1 meter or 100 centimeters. We have 4 vertical. Just change the number and then create the similar. That create this line and then use the measure tool. Okay, equal. So we can delete this after you define the distance between the line. Okay, now is the horizontal line. So we know the distance of the line is 2 meters. So we use the offset function to define the new line based on the reference line. Okay, we finish defining the grid construction line for the plan. Let's put it on good position and make it more attractive. Okay, now we define the level in the elevation. Actually, in the elevation, we have two levels. So for our project, the level 2 and level 1 have a distance of 1 meter. That means the support on the left hand side is 1 meter higher than the support on the right hand side. Okay, next step we define the foundation. So we use the structure step tool. The plan dimension of the foundation is the 3 by and 6 meters. So we change this to 300. Yeah, and 6 meters. That's okay for the first one. And for the second one, it's the same. We use a rectangle to change to 300 centimeters. Okay. The thickness actually is that 150 millimeters. Or we change something more important. We define for 2 meters. So we change the thickness to 200 centimeters. Okay, so for the first one, for the second one is the same. We change the thickness. We create the 2 meters tile foundation. Okay. And we change the thickness to 200 centimeters. Now the foundation and right hand side is level constrained at the level 2, and we want to change this to level 1. And the foundation on the left is not in good position, so let's modify it. Okay, so now we put the truss system in the model. The family 1 is selected, and we just put it in the good position. And the height of this truss actually is 180 meters, so we change for the 200 centimeters, so 2 meters. That's okay now. Okay, you can see that the bearing vertical for the truss is in the center. That's why we see the bottom beam is overlap here. So just select the truss and change the bearing vertical to bottom. Now we add the support truss system for the bridges. It's in the right of the bridge. So we need to choose the family of the category structure columns. So you go this and choose this library structure column, wood and timber for column here. We select one type and then we change the dimension by creating a new one, 3 times 6 centimeters for column. Okay, we change the dimension 3 and 6. Okay, to put the column in the good direction of the section, you use the space button to tap the space in the keyboard to change the direction of the column. Okay, that's okay now. Yeah. Add the 2 column, and now we add the horizontal beam. You can use the 3D model view, or we can use the plan view, and we apply on the level 1 for the section for the beam. Okay. As we use the structure template for this project, We can see the analytical model in the three-dimensional view. To hide this analytical model in this view, we need to modify the property of this view by using visibility and graphics function here. And just uncheck the box. Okay, now we have adjusted the shape of the model in this view. And we don't see the beam here, so just change the from center to the bottom. Now to create the diagonal bar, we can use the beam element and draw it in the three-dimension view. And you need to check the box of 3D snapping to activate this functionality. Okay, and we change the set specification is on bottom, so we change to the center. Okay, that's okay. Now we can release the charts from the family. You need to use the remove truss family to be able to modify the individual elements. You can see now you can select and modify the element one by one. We will notch the bar in this area. So to do that, we need to extend X bar, and let's do it, and you can understand why. To extend the beam element to their joint point, you select the point and right-click and choose the Disallow joint option. Sometimes it's work for the double click, but sometimes it's not work. So just right click and choose the Disallow joint. It won't take long. Just check the analytical model. You can see that the elements are joined together at the top of X bar. And now I think we can do the notching now. To go to modify, notch, and then select the element to be notching, and then to select the element to notch the selected. That's okay, I think. Now we copy it to create the second main chart system. So it's easier to select the system to copy in the elevation view and then do the copy in the plan view. Okay, now we define the link between two main chart systems. In fact, for the bottom link, we define the beam on the level 2. So we select the level 2 and uncheck the 3D snapping. It's important because we want to select only the point in the plane of level 2. So uncheck the 3D snapping for this case. So we change the Z justification of the beam because you want to the position of the beam is consistent with the beam of the truss system. As you can see here, that's okay. If I when creating the 3D model on Revit, using the plan and elevation view is very useful. As I explained to you, that helps us to create a model accurately. In fact, the definition of the diagonal element in the bottom area is easier by using the plan view on level 2. But we do not have a specific plan for the diagonal element in the top area, as you can see here. In fact, you can tell me that it is easy because we can create the element directly on the 3D views by using the 3D snapping tool. That's like this. Okay, I tried, but you can see it's not evident to select the pointer on 3D view. So it's difficult to select this one. Yeah. No for this one. Even I move around the area, but this one is the work. So I will show you a technique to create this element. So first we need to create the third level consisting of the top level of the truss. We need to create the new level here and level 3 with a distance of 2 meters from the second one. Now you can see a plan for level 3 has been created, and you can use for the placing the diagonal bar. Here is the element that you can see in the plan of level 3. Now you can place the diagonal beam for the top area of the bridge. And the 3D snapping is always active and need to active in this case, but it's work more effectively in this case because instead of snapping in 3D view, the point will be snapped accurately and more quickly in the plan view. Let's see. In fact, pay attention when selecting the point. The element containing the selected point will appear, and it is useful to choose the right one. And I will give you a case that is not work. So it's not work now because we didn't choose the element. The element contain the point is not appear. It's appear, that's good. Appear, good. The same for this. Okay. Yes, you can see it's appears. That's okay. Okay, that's fine. As a diagonal. Okay, that's fine. Everything go well, I think. We can see that it's not able to create the beam using the snapping on 3D view. But just practice and you can find, I think, you can find the way that is the best fit for you. And if you have another solution, thank you for sharing with me. And you can see that the link in the support area has not been defined. So let's do it. You can see. So we will select the plane of level 1 to place the beam element. Select level 1. Inactivate the 3D snapping. Okay, we just change the justification of this beam from center to bottom. Okay, that's okay, I think. And now I will show you how to hide the grid and export the image for your report. So you select all the instance visible in view and right click and select the hide in view option. So you go to file export and here images and animation, you choose this one, and here you can see you can choose define the format of the image. So you and the TIFF format give you an image with high quality. Okay, let's check the Balsa bridge. That's fine. So you can use this image for your report. And here I also create the image for my presentation.